All right. This is the Work, Power, Energy, and Machines test review. And this is off of the worksheet that you received in class, which is the practice problems 1 through 19. We're going to start at number 1. So let's go. Number 1. Oops. Let me go back. My machine's being funny. Number 1. We're told to calculate the work done as a 100 Newton force pushes a crate 5 meters along a factory floor. So we are going to say that our force is 100 newtons and our distance is 5 meters. Yes. And so to find work, work is force times distance. So all we're going to do is 100 times 5. And this is newtons and this is meters. So this is 500 Newton meters. And another way to say Newton meter is a joule. So both of those answers, either or, would work. For number 2, we're supposed to find the work done by a person who carries a force of a box that's 50 newtons for a distance vertically up a ladder of 3 meters. Now this force was the weight and it was up and down, and this is vertical as well, so that's why we get to use these together. And work is force times distance, so we're going to have 50 newtons times our 3 meters, which is going to give us 150 joules, or you could have Newton meters. Either one would work. On number 3, we want to know the potential energy of a box that's 50 newtons and it's raised 3 meters. Okay, well, potential energy is mass times gravity times height. Well, believe it or not, mass times gravity is just force. And we're told that it's a 50 Newton box, so we already know that force. And we're given the height, which is really just a distance of 3 meters. So we're going to take the potential energy to be 50 newtons times our 3 meters again. So we'll also have 150 joules. So it's important to realize that force is the weight, and force is always in newtons. So the mass and the gravity have already been taken care of on this problem. Number 4. Number 4 says calculate the power. Well, power is work divided by time. And we're told that we have a force of 50 newtons and a distance of 3 meters high and a time of 3 seconds. All right. So we're going to say also work or power could be force times distance divided by time. Well, your force is 50 newtons, your distance is 3 meters, and your time is 3 seconds. So we're going to multiply, and 150 divided by 3 is going to give you 50, and that would be in watts because the units for power is a watt. Number 5 asks us to calculate the kinetic energy. Kinetic energy is mass times velocity squared over 2. And then it tells us that the mass of the object is 10 kilograms. It's a cart and it's a velocity of 4 meters per second. So now we're just plugging in KE equals 10 kilograms times 4 meters per second squared divided by 2. When you type that in the calculator, you get 80. Now 80 is joules because energy is really just a form of work. So the units are joules. Moving on, number 6. Number 6 says calculate the change in kinetic energy when the speed of a 10 kilogram cart, so we have the mass is 10 kilograms, increases from an original velocity of 4 meters per second to a final velocity of 10 meters per second. All right. Well, we're going to need to find our final kinetic energy minus our original kinetic energy. Okay, because they want us to find the change in kinetic energy. So we're going to say mvf squared over 2 minus mvo squared over 2. And then we're going to fill in 10 kilograms times 10 meters per second squared divided by 2 minus 10 kilograms times 4 meters per second squared divided by 2. When you calculate this in your calculator, you should end up with 500 minus 80, which is 420 joules. All right. Now, number 7 says, how much work is required to make this change in kinetic energy that we just solved in the previous problem? Well, in your notes, we talked about how the change in kinetic energy equals work, and that's called the work energy principle. So, how much work is required? The same amount as the kinetic energy change was. So, it's 420 joules because they're the same amount. Because the change in kinetic energy is equal to work. So that's important to realize that you understand that those two things can be the same. All right, moving on. Number 8, how much work is done by a person who picks up a crate? So we have to pick it up. When we pick it up, we're going to give it potential energy. Okay, so we have to pick it up first, and then we have to send it flying at a speed of 4 meters per second. So once we make it move, it's going to have kinetic energy. So we first have to solve for the potential energy, which is going to be mass times gravity times height. And then we're going to solve for the kinetic energy, which is going to be mv squared over 2. So our mass, and what problem am I working? I'm working number 8. Sorry, everyone. So the mass of the object that I'm picking up is 3 kilograms because it's a crate. And I'm going to raise it a height of 12 meters. No, not 12, 2. My bad. 2 meters off the floor. And then I'm going to send it with a velocity of 4 meters per second. So I'm going to say 3 kilograms times 10 meters per second squared, which is gravity, times my height of 2 meters, plus my 3 kilograms times my velocity of 4 meters per second squared divided by 2. So I have to do both these pieces together in order to get the answer. So this ends up being 60 plus, when you do this calculation, it's 24. And both of these are going to be joules. So our final answer is 84 joules. All right. Then we have number 9. Okay, on number 9, you've dropped a falling object and it has a kinetic energy. Oops, let me change color, sorry. Of 5 joules. And it has a potential energy of 10 joules. So the total energy it has at the beginning is 15 joules, and this is its original energy. Okay. It then, as it continues to another point, you figure out that it has another potential energy of 3 joules, and you want to know how much kinetic energy it has. Remembering that if it starts out with a total energy of 15 joules, it has to end up with a total energy of 15 joules. So that would be our final energy. So 15 minus 3 would be 12 joules of kinetic energy. And it's going to increase in number from what it was previously because it's falling. So it's accelerating, its speed's going up, and we're good to go. Let's keep going. All right. Number 10. Number 10, calculate the efficiency of a machine that has a useful energy output of 220 joules when the work input is 300 joules. So that would mean that this one was my WO and WI is going to be 300. So our efficiency formula is efficiency equals work out over work in times 100. So we have 300 divided by 220 multiplied by 100, which will give us an answer of 73.33%. Okay. So again, it's just using the formulas. Remember, these formulas are on the tax formula chart and on your physics formula chart, so it shouldn't be hard to come up with them. 11. 11, we have use the conservation of energy to find an equation for a speed of a freely falling object that falls from rest, which means it only had potential energy at the beginning, and all of the potential energy is going to turn into kinetic energy. So we're going to say PE equals KE, and then we're going to expand these out. We're going to say MGH equals MV squared over 2. And it wants us to solve for V. So we want to look for this letter right here. So if that's the case, then we are going to be able to cancel out our mass because it's the same on both sides. So we'll then have 2GH equals V squared because I have to multiply by 2 on both sides. And then since I have V squared, I'll have to take the square root, and whatever you do to one side, you have to do to the other. So V ends up being the square root of 2GH. And that's all they wanted you to do was just solve it without numbers. So they have a height of H, we know gravity, and we solved for V. Number 12. A pole vaulter wishes to clear a 4-meter bar. So we have a height of 4 meters. And how fast must she run? And all her kinetic energy is going to convert into potential energy. So we want to solve for her V. So we're going to say KE equals PE, which means we're going to say MV squared over 2 is going to equal MGH. Because there's one mass on each side, we can cancel it out. We'll end up with our V squared over 2 equals 10 meters per second squared for gravity and a height of 4 meters. We'll need to multiply both sides by 2. So we'll multiply by 2 over here. So 2 times 10 times 4 gives us 80. And V, we're going to take the square root of 80. So V is going to be 8.94 meters per second.